This project is on the Library of Birmingham by Lewis Warburton. Introduction. Partners that were involved in the construction of the Library of Birmingham include Birmingham City Council, who acted as the client, Meccano, who acted as the architect, Capita, who acted as the client's project managers and their cost consultants, Borough Happold, who acted as the engineers, and finally Carillion, who were the main contractor. Challenges. There were several challenges that were present in the construction of this project. They include the fact that the project had a fixed budget and end date which could not be exceeded, as well as a quality expectation in the scheme like no other. However, the scheme was finished on time and under budget, with a budget price of £193 million and a final cost of £188 million. The Library of Birmingham is also located in the city centre. It is surrounded on all faces with regular public traffic and civic events traffic. This presented issues with the traffic management of both vehicles and pedestrians, whilst also providing difficulty with the routing of deliveries to the scheme, as it is located in a highly populated area. The scheme also had to ensure the preservation and integration of the existing repertory theatre building into the new library system and infrastructure. This required careful and extensive planning and design. Facade materials. Prater and Linde facades provided the roofing and facade. They installed cladding with kingspan and composite panels and single skin cladding sheets. They also produced capping to the perimeter roof upstands using aluminium powder coated products. In total, Prater has waterproofed 7,500 square metres of the library, which also includes an area on the ground level podium along with a biodiverse roof garden. The library is surrounded in 8,500 metres squared of unitised facade with a feature of curved aluminium. The 5th and 6th floors were constructed with 3 metre wide and 6 metre high gold anodised cladding. Richter states that there was also 1,500 metres squared of steel framed ground floor glazing with soffits and also a number of bespoke doors. Meccano. The library was designed by architect Francine Huben, who worked for the Dutch studio Meccano. She explained that she wanted the library to be a people's palace. She also wanted the library to be a warm and welcome environment, enticing everyone in, not just the rich and intellectuals. The library is made up of 4 stacked large cubes. It includes a sunken amphitheatre, and part of the library extends beneath a public square. There are reading rooms that branch out from a staggered rotunda. Allowing a lot of light into the building was a major concern of this project. As a result, large portions of the building was faced with glass in order to do this. Construction systems. The Library of Birmingham used a heavyweight construction system. In achieving this, the Library of Birmingham makes use of a concrete structure, comprising of efficient post-tensioned concrete slabs, concrete transfer walls, and concrete arches. The use of this heavyweight concrete structure helped the Library of Birmingham achieve excellent BREEAM status by ensuring that thermal mass was incorporated into the library's construction, developing efficient operational energy usage. This was a key aim of the project from the start, with energy efficiency being one of the main focuses. Concrete structures are durable as they result in lower maintenance costs and also lower life cycle costs when compared to other construction systems such as timber frames. The concrete structures are also inherently fire resistant. This results in superior levels of public safety and protection, which is of importance in public structures that receive as much foot traffic as structures such as the Library of Birmingham. Carillion decided on the use of a concrete structure over a steel frame structure, as this solution benefited from smaller delivery loads to a congested site, minimising the effects of the difficult city centre location, whilst also reducing programme duration, which in turn helped to lower the costs of the scheme. Steel frame ground floor glazing. However, Birmingham Library does also incorporate the use of steel frames for its ground floor glazing as well as other areas. The benefits of this include that steel creates a lightweight frame, which when compared to the usual concrete is certainly true. This is of vital importance in the construction of large buildings such as the Library of Birmingham, where the weight of the building can be enormous. Any weight saving has the potential to drastically reduce the costs via reducing the costs and size of the substructure. This is because foundations are not required to be able to bear as much weight if there is steel used as in place of concrete. Rodriguez also states that steel frames may be a quick and high quality solution to deliver zero carbon housing without compromising the user's comfort. However, steel frames might present a risk of overheating today and in the future, with Rodriguez going on to say that simulation has shown that a low-energy house studied is likely to overheat. Overheating is aggravated when future climate scenarios are considered. Whilst this study was conducted on a house, its implications may also be seen in larger structures, such as the Library of Birmingham. Aluminium rings. The Library of Birmingham is also clad with a skin of overlapping aluminium rings to represent the City of Birmingham's craftsmanship. Aluminium is a good material to use for this, as it is extremely lightweight, along with being highly resistant to corrosion. Aluminium oxide actually has the effect of strengthening the aluminium. Aluminium is much more expensive than steel, although there is the potential of the installation of steel cladding to be of greater cost, as larger cranes would be required for the installation due to the increased weight of the steel. It also has to be considered that steel would rust, and as the aluminium rings are for aesthetic purposes, this would not be beneficial for this scheme. Substructure. The site and ground conditions. The Library of Birmingham site lies near a listed building with shallow foundations. As well as this, there is also an underground railway tunnel which runs near the site. Due to this, the extent and depth of the basement had to be considered thoroughly in order to minimise any impact on these structures. Alongside this, ground conditions included contaminated canal basins, overlying soft natural materials, and overlying rock. Due to this, the Library of Birmingham's basement was set to be at rock surface level. This enabled soft ground materials and contaminated material to be removed easier, whilst also eliminated costly excavation further into the hard rock, and at the same time, the hard rock provided a stable foundation for the building to be built upon. The Library of Birmingham's foundations are made up of a combination of board piles and pad footings. The use of pad footings has an advantage over piles of that it reduces costs and reduces the foundation programme due to the easier and cheaper installation of these foundations. However, board piles were also necessary. Board piles in sandstone were used due to their capacity to carry large loads and to minimise disturbance to neighbouring properties when compared with other piling systems. Due to the size of the Library of Birmingham, piling was essential. Board piles was deemed to be the least disruptive use of piling. Environmental considerations. Aquifers. Carillion was recognised for its excellent work when it came to managing the environment. They installed an aquifer at the Library of Birmingham to ground source cooling system. It is a renewable energy source that uses groundwater to provide the library's heating and cooling system. It achieves this by using a production well. Groundwater will then be abstracted from an aquifer. Following heat rejection via a heat exchanger in the building, the groundwater will then be discharged back to the aquifer via an injection well. Constant groundwater temperature can thereby be maintained throughout the year with this open loop system. This further helped the Library of Birmingham achieve its excellent BREEAM status. The Library of Birmingham also benefits from its use of green roofs. Green roofs are widely regarded to create conservations and restore habitats. They also have greater ecological diversity than the standard roof and can provide a habitat for rare species of birds. However, William et al. State that there are a few studies that have strong enough proof that they are truly beneficial, including repetitive testing of ecological studies regarding green roofs. There's also the fact that whilst green roofs may help improve biodiversity on the green roof, they may not match ground level diversity restoration products. It should therefore be considered whether ground floor restoration projects would be more beneficial to the scheme before proceeding with the green roof. Grey water usage. Grey water is a wastewater from urban areas. This water can come from showers, hand basins, washing machines, but excludes toilet streams. This is most likely due to the fact that it would contain dangerous pathogens in this brown water. Grey water has low-level pathogens that could contaminate, and nitrogen, meaning it is receiving more attention as it has potential to be reused. Whilst recycling is always seen as a positive, specific guidelines for grey water reuse are unfortunately not available. Lee et al. Raises the issue of the treatment for grey water. This could mean that grey water recycling techniques can vary widely, which raises issues of costs. Also, public perception may be an issue. When asked, the percentage of respondents willing to recycle grey water decreased from 88% from within a person's own home down to 50% when conducted throughout a neighbourhood or within a hospital or public building such as the library. The Birmingham Library uses single skin cladding sheets. However, this may not have been the best option. Single skin claddings are not particularly great for insulating sound and noise. The sound reduction of single skin cladding displays pronounced dips in the mid-frequency range. These dips can cause single skin cladding systems to be inferior when insulating sound. As a result, the Library of Birmingham may have benefited from double skin cladding. This is because it reduces heat loss by reducing the speed of airflow entering and leaving the building, maintaining a more steady temperature. Birmingham Library have also incorporated Kingspan composite insulation panels into the construction of the library. growing use of high-performance composite materials has increased the development of the design of these laminates. Due to their high strength, composite plates are usually thin laminates. This has the advantage of reduced weight, but due to their thinness can often mean that they can buckle. The wide use of natural light across the Library of Birmingham has also added the advantage of reducing costs and emissions from electricity. The Library of Birmingham has, where possible, taken advantage of natural daylighting to provide a comfortable environment throughout the building. The Library of Birmingham's lighting matches the architectural structure of the building while providing the necessary lighting for each floor level. Lighting is largely delivered from high-level downlights to meet the Chartered Institute of Building Service Engineers' recommendations for light levels for the wide variety of spaces across the floors. To meet the energy targets of the building, the downlights are warm colour temperature metal halide fittings with integral electronic control gear, the most energy efficient systems currently on the market. Finally, the Library of Birmingham incorporates the use of a CHP unit. CHP stands for Combined Heat and Power, which captures and utilises the heat byproduct from the electrical generation. It is believed a CHP system can reduce carbon emissions by 30% and save energy costs by 20%, further increasing the energy efficiency of the Library of Birmingham. The extra heat generated by electricity production is matched to where heat is in demand, which alternatively would have been supplied by an additional boiler. CHP systems are highly efficient, making use of the heat which would have otherwise been wasted. Thank you for listening to my presentation on the Library of Birmingham.